Next, 7.2, functions and graphs. So if you'll recall from 7.1, we talked about the idea of a function and the idea that every input gives exactly one output, being the defining feature of a function. So what we're going to talk about today is all of the ways that we can look to try and figure out if that is true, if that's a function or not. So last section, we basically just kind of looked at tables mostly, and there are 4 different ways to look at a relationship. You could look at it as a table, you could look at it as an equation, you could look at it as a graph, and you could look at it as a diagram. Sometimes those diagrams are a good way to be able to see if it's a function or not, but what we're going to focus on today is graphs. There's a really easy test that you can do to figure out if an equation represents a function based on its graph. That test is called the vertical line test. And what that is that a graph does not represent a function if you can draw even one vertical line that crosses the graph 2 or more times. So what that means is that you're going to have to look at all of the possible vertical lines that go through that function or that line or that curve or whatever it is that you've graphed. And you're going to have to decide if you think that a vertical line will ever cross that graph 2 or more times. So it's really a quick and simple way once you've got it graphed, and so what goes along with that today is a little bit of a review of graphing. So we'll go ahead and do that. Make sure you get this vertical line test copy down into your notes. Go ahead and pause the video for a second if you need to do that. Okay, we're going to do 2 equations first here, y equals 3x plus 1 and y equals 4. So let's start with y equals 3x plus 1. I am going to use the fact that it's in slope-intercept form to help me graph it. I've got a positive 1, a plus 1 here for my y-intercept, so I know that means that on my y-axis there's a point at 1. And then I know that the number with x is the slope. That's 3, or that's the same as 3 over 1. So that's going to be a rise of 3, 1, 2, 3, and a run of 1 from that point. I could go up another 3 and over another 1 if I wanted to, just to get another point on there. And then I can take and make a line that connects those points. Okay? So now we've got to do the vertical line test. We've got to decide if this is a function. Now that we've have it graphed, we can do the vertical line test. So I'm going to look at the function, and I'm going to look at all possible vertical lines. So I'm just going to go ahead and draw a vertical line here. And just moving that around, I can see that no matter where I move this vertical line, it's only ever going to cross our equation at one spot. So that means that this has to be a function. So let's go ahead and write function. Okay? All right, so let's go ahead and graph y equals 4. So I'm going to start graphing some points. This one's a little different. It's not in slope-intercept form, but I can just think about graphing all of the points where y equals 4. So if I think about, okay, y equals 4 here, equals here, it really equals 4 all along this horizontal line. So I can go ahead and draw a horizontal line. Oops, I didn't really want that to be green, but you guys get the picture. There we go. Representing all the points where y equals 4. So once again, I'm going to use that vertical line test to determine whether it's a function, and I'm just going to take my vertical line and move it across there, and I can see, yeah, it's only really going to ever cross at one spot, no matter where I move it. So once again, this has to be a function. All right, let's see 2 more examples. Y equals 1/2 x minus 2. So this is a little different with our graphing. We've got a minus 2, which means that my y-intercept is going to be at a -2. And we've got a 1/2 x. So that's a rise of 1 and a run of 2. So I'm going to go up 1 and over 2. Up 1, over 2. Up 1, over 2. Then I'm going to go ahead and graph. Connect the points, make a line. And then let's go ahead and use a vertical line once again. Make sure. Yep, this vertical line is only going to ever cross there at one point. So once again, has to be a function. Okay, x equals 5. So not in slope-intercept form, right? X equals 5. I want to look at all of the points where x has to be 5. So x has to be 5 here, here, and here, and here, and here. So now I've actually got my equation giving me a vertical line. So if I bring my vertical line over here, I can see that if I move them right over top of each other, they're going to cross at every single spot. So obviously that's more than once, that's more than one point where they cross. So the equation x equals 5 is not. It's our first example of not a function. Okay? So what I would like you to do before you come to class tomorrow is look at each of these graphs. Look at each of these graphs. Don't worry about what the equation or the table might look like, but use that vertical line test to decide whether you think each of these pictures is a function or not a function. Good luck!